So let me kind of explain to you guys how to do this, and then we'll move from there. All right. So the ideal gas law is PV equals N, R, and T. Okay. This is pronounced Pivnert. Pivnert. Okay. Morning, Alexis. Sarah. Morning. Hey, yes. All right, so P is pressure, which could be an ATM, millimeters of mercury, torr, KPA, or KA. PA. Okay, those are the different values for that one. And if you don't want to take these notes, I can go ahead and take a picture of these notes and put those on Classroom. Is that something that you guys would like? Thumbs up, thumbs down. All right, let's do it anyways. Okay. V is for volume. And the volume will be measured in liters, always. Okay, this is liters. All right. N is the mole quantity. Now, when was the last time we talked about moles? Last time we talked about moles was stoichiometry, and that is actually what. When stoichiometry combines with gas law, that's how we get the ideal gas law. So there is a stoichiometric component to this as well. We could totally find out how much of a certain gas would be produced or how much of a certain gas we need based off of that N value right there. Okay, the R value, and I'm gonna rewrite this part. This looks like crap, but. The R value is called the ideal gas, or the gas constant. I'm just calling it constant R value. We'll just call it R value. It's a gas constant. Okay? And the gas constants, it's solely dependent on the P unit. So like a rapper or a gang. The P units. Yes, I know you're laughing. It's funny. All right. So there are lots of R values, okay? If your pressure is an ATM, then your R value is going to be 0.08206. All right? If your pressure is in millimeters of mercury, or torr, then your R value is 62.4. These are not calculated numbers. These are found based off experimentation. So in case you're wondering how I got these, number one, I memorized them. And number two, these were found when people were working on ideal gas law back in the 1700s over in France. I'm drawing a blank on who it was right now. I think it was Sir Davy Humphrey, I think was who found it. He was rich, but he was also brilliant scientist. No, he was in England? I don't remember. And I'll give you the R value for KPA. No, I'm not going to give you that one. We're going to do these two, okay? So any problems you see, you're either going to have a problem with ATM on it that deals with the ideal gas law, or you'll have millimeters of mercury and torr. If it's a different R value, I'll just give you the R value. Okay? How's Marion? Fresh, what's up? All right, and the last value is T. That value is T for temperature. Temperature. And it is always in Kelvin. Always. All right, so let me write this out where it's just, instead of having all this writing stuff on here, let me write it out down here where it's just the thing. That's how I should have done it the first time. Should have done it like that, dang it. There we go. So this is in Kelvin. This is ATM, millimeters of mercury, or torr. This is the mole quantity. Hey, can you turn it down, please? I'm on live right now. Hey, can you please turn it down? Okay, thank you. Man, dealing with a kindergarten in the morning is pain, but I don't know if you guys have any kindergartners, brothers, and sisters, but holy mackerel. This girl be getting at me. All right, ATM, millimeters of mercury, torr. We'll just leave it at that. All right, so there you go. Okay, so let me write out the very first question for you. We're gonna do an example problem for this. So let me write this out. Give me just a second. Do you guys want me to go ahead and upload this worksheet for y'all to work on? So that way you can see what I'm doing? Would that help you? Or see where the problems are coming from? So I could totally upload that to Classroom right now for you. I'm going to do it anyways. Later, but I can do it right now. It. Okay, I'm not doing that right now. Okay, I'm busy right now. You have to give me some time, okay? I really wish IG would let you turn this thing sideways because you get a better screen that way. It's dumb. All right, so what we do, since we know that since it has moles in it, we need to go ahead and write our variables out, right? So what are the variables we're using? We're going to use P, V, N, R, and T, okay? You will always write out your variables. We do this the exact same way that we just did the gas law stuff, right? Exact same way. You write these variables out, and then you write out the equations you're going to use. PV equals